Okay, so I'm going to do examples that are similar to the ones on page 42. I'm not going to do the actual problems on page 42, so I'm just going to make up similar problems. So if I look at number A, or letter A, oops, okay. So letter A, a similar problem could be 3x minus 2 to the, we'll say the second power, so it kind of matches. So if we wanted to take the derivative of that, normally we would have to write out 3x minus 2 times, this is really hard to write with, 3x minus 2, and then you could use the product rule, or you could FOIL that out and use just the power rule, but we're going to do this with the quotient, or I'm sorry, the chain rule instead. So to do the chain rule, this 2 comes out front, so we would have 2 times 3x minus 2, so you leave the inside the same, and then you subtract 1 from this, so that's just 1. So that's the first thing, is the power rule. We left the inside alone, and then you multiply that by whatever's on the inside, which in this case, the derivative of it is 3. So your answer would be that, which you could simplify to say 6 times 3x minus 2. There's no reason to write the 1 there. And you could even simplify it a little bit more and say 18x minus 12, but that's unnecessary. You just simplify as much as you are comfortable with. So part B, a similar example could be, I'll follow the same sort of style that he has, 3x minus 2, but then let's make this to the 4th power. So if we do the derivative, the 4 comes out front, keep everything inside of the parentheses the same, reduce that exponent, this one here, by 1, so that becomes cubed. And then now we take the derivative of the inside, which is just 3. So this would be your answer here. For C, we can do 3x minus 2 to the 10th power, let's say. So that's going to be 10 times, keep the inside the same, reduce that by 1, and then multiply again by the derivative of the inside, which is 3. And then our last one, we'll do the 4th root of 3x minus 2, which is the same thing as saying 3x minus 2 to the 1/4. So if we take the derivative of that, pull the 1/4 out front, keep the inside the same, reduce that 1/4 by 1, which means we're subtracting 3/4, so that, or I mean 4/4, so it's going to be to the negative 3/4, and then multiply that by the derivative of the inside, which is just 3. So that would be your answer there. Okay, so now let's do example 1. Well, those are the examples basically that I just did. I'm going to do something similar to example 5 on that same page 42. Let's say that y equals 3 over 6x minus 1. And I don't really need those parentheses. I'm not sure why I wrote them. Okay, so you could use the quotient rule with this, but you don't really want to have to mess with that. So we could just move that 6x minus 1 up to the numerator so that 3 stays there. We have 6x minus 1. And then this was to the 1 power. We just didn't write it, so now it's to the negative 1 power. So if I take the derivative of that using the chain rule, so that negative 1 comes out front, makes that a negative 3. Keep everything inside the same, and then subtract 1. So now we have negative 2, and then multiply by the derivative of the inside, which is 6. So that would be your answer on that one. I'll do an example similar to example 6. So we have y equals 4x cubed plus 3x minus 5, and we'll make that be to the 5th power. Okay, so first you take that 5 out front, keep everything on the inside the same, reduce the exponent by 1, and now we multiply by the derivative of the inside, which is going to be 12x squared plus 3. Whoops. Oh, I'm at the edge of the screen, but that's a 3 there, and then close the parentheses. Okay, so let's go ahead on to the next page. And we'll do something similar to example 7, 8, and 9. So for example 7, let's say that we have y equals 13 plus 2x to the 5, 6. Okay, so the derivative of that, we're going to pull the 5, 6 out to the front, keep the inside the same, subtract 1 from this, so that's going to be negative 1/6, and then multiply by the derivative of the inside, which is just the 2 from the 2x. So that would be your answer for example 7-ish. Example, something similar to example 8 could be y equals 10. I'm going to make this the cube root of 4x squared plus 2. Okay, so we can rewrite this and make it 4x squared plus 2 to the 1/3 power. That's a little easier to work with. So now the 1/3 comes out front. This 10, he's just staying there. Nothing happened to him. Keep the inside the same. Subtract 1 from this, which gives us negative 2/3. And then multiply by the derivative of the inside, which is 8x. So that would be your answer for something similar to example 8. Something similar to example 9 could be, let's say, negative 15 over, I'm going to make it the square root of 12x plus pi. Okay, so again, I'm going to rewrite this and make it negative 15 and then 12x plus pi, and this would be to the negative 1/2 power since it was in the denominator. So y prime is going to be the negative 15. That just stays there. The negative 1/2 comes out front. Keep the inside the same. Subtract 1 from the exponent, so that's negative 3/2. And now we multiply by the derivative of the inside. Derivative of 12x is just 12. Derivative of pi is 0, so I'm not going to write that. Pi is a constant. Okay, so that was up to example 9. Now we'll get into the more difficult problems. So if we look at 10, something similar to 10 could be 4x cubed and then 6x plus 2 to the 5th power. So we're going to have to use the product rule because we have this thing times this thing. And then we're also going to have to use the chain rule because this 5 is now on the outside of this. Okay, so if we do y prime, if I'm using the chain rule, I take the derivative of this guy first. So that's going to be 12x squared. Keep the other guy exactly the same. Plus, now we take the derivative of this guy and keep the other guy the same. So I'm going to go ahead and write the other guy, 4x cubed. And then the derivative of this guy, whoops, this guy right here would be 5, 6x plus 2 to the 4th. So that was our chain rule. And then times the derivative of the inside is times 6. So that would be our derivative. You don't have to simplify it for now. Just go ahead and leave it like that. Let's try 11 and see if I can fit it here. So number 11, we could have something like 5x times the cube root of 3 minus x cubed. Okay, so again, let's go ahead and rewrite this as 5x times 3 minus x cubed to the 1/3 power. So we're going to have to use product rule again, plus the chain rule because of this 1/3 outside of this stuff. So for the product rule, we take the derivative of the first guy, which is just 5, keep the second guy the same, plus, and now the first guy stays the same, and we take the derivative of the second guy, so that's going to be 1/3 times 3 minus x cubed to the negative 2/3. When I subtract 1, I'm running out of space. And then times, so times the derivative of the inside, which would be negative 3x squared, negative because it's minus right there. So this would be on the same line. I just ran out of space. Okay, so let's try something similar to 12. So let's say that I give you 4x plus 2 over 3x minus 1, and we'll make that cubed. So now here we have the chain rule. The cubed is on the outside, and then we're going to have the quotient rule going on the inside. So y prime, use the chain rule first since it's on the outside. 3, keep everything inside the same. And reduce that by 1. Now we have to take the derivative of the inside. So that's going to be our quotient rule, which is low d high minus high d low over low low. So low is 3x minus 1. D high is just the 4. Minus high, which is 4x plus 2. Oh, I'm out of space. Plus 2 times d low, which is 3. So that's a 3. And it should go next to the 2 there. All over low low, which is 3x minus 1 squared. And then this whole thing, you would close off the parentheses here. So that would be your derivative. That's all you have to do. So again, low d high minus high, d low is right there, all over low low. I'm going to erase this to do 13 so I have more space. So 13, let's say that we do x squared over 4th root x minus 3. So to take the derivative of that, you could either make this be a product rule and move that up to the top. I think I'm going to go ahead and do that, or you could use the quotient rule. So for me, it's easier to write it like this. Oops. And then that's to the negative 1/4. So that's a little easier to see, and then that's just the product rule. So here's product, and then this negative 1/4 is going to make us have to use the chain rule. So we have y prime equals the derivative of the first, and then keep the second the same, plus keep the first the same, and now do the derivative of the second, which is going to be negative 1/4 times x minus 3 to the negative 5/4. And then the derivative of the inside is just 1, so I'm not going to put that. So that would be our answer. Okay, for something similar to 14, we could do cube root of x squared over 3x minus 2. That's a 3. So you might want to rewrite this as x squared over 3x minus 2 to the 1/3 power. That's a little easier to see. So that 1/3 is going to give us the chain rule, and then in here we could do the quotient rule. You could also put this up next to this one with a negative 1 exponent and make it product rule, but we might as well just leave it like this. So we're going to have y prime equals 1/3 times x squared over 3x minus 2. That stays the same. Subtract 1, which gives us negative 2/3. And then the derivative of the inside is going to be low d high, which is 2x in this case, minus high d low, which is just 3, over low, so 3x minus 2 squared, and then that whole thing, you would close the parentheses, and that would be your answer. Okay? I'm going to pause this, and then I'll do 16, or I'll do 15 through 19 in a little bit, because I have to start class. Okay, so now I'm going to do a problem similar to number 15, except hold on a second, I don't have a pen. Okay, so number, this is not on. Give it just a second. Okay, number 15. So if we go to number 15, let's say that we use y equals 3x to the 4th plus 2 times the square root of 2 minus x. Okay, so here, if I rewrite this just for simplicity, we're going to have 3x to the 4th plus 2 times 2 minus x to the 1/2 power. So you see that we have the product rule because we have two things being multiplied, plus we also have the chain rule because that 1/2 is outside of all of this stuff in here. Okay, so the product rule comes first, it's in order. So I'm going to do the derivative of the first, which is 12x cubed, and then keep the second intact, plus the derivative of the second. So I pull that out, 2 minus x to the negative 1/2. And then the first one, or I'm sorry, then the derivative of the inside is going to be -1. And then times this guy, which doesn't change. So, and I think I'm going to run out of space. Yep, so there's a 2 there and then close parentheses. So again, I did the derivative of this first guy, kept the second guy the same, and then did this derivative of the second guy using the chain rule, and then kept the first one the same. Okay, so now let's erase these. Where's the button? Okay, and so I'm gonna say for number 16 through 19, we're gonna say f of 3. Actually, well, I'll just make up new numbers. So f of 3 is going to be 5. F prime of 3 is going to be 2. G of 3 is going to be 4. And G prime of 3 is going to be -1. And then the last one that I'm going to need, I'm not sure what the last one's going to be, so I'll fill that in when I get to it because I haven't made up a problem ahead of time. So that way it matches what's on page 43, just not the same numbers. And we're going to find the derivative in this case at x equals 3 instead of at x equals 2, like he's saying in the problem. So 16, I'm going to say f of x squared, just to make it a little bit different, times g of x. Okay, so if I do that, it's going to be the product rule and then also the chain rule because of that 2 there. So I'm going to take the derivative of the first one, which is going to be 2 times f of x. So that's 2 comes out front, the f of x stays the same, and then I take the derivative of the inside, which would be f prime of x. Okay, and then g of x stays the same, that doesn't change. Plus, now this first part stays the same, so f of x squared. And then we take the derivative of the second part, which is g prime of x. So again, I took the derivative of the first one using the chain rule, kept the g of x the same. Then I took the derivative of g of x, which is just g prime, and then kept the first one the same. So now, if we plug the numbers in, since we want it at x equals 3, 2 times f of x, or f of 3, is going to be 2 times 5. Oops, that's not supposed to be plus. Make that times. F prime of 3 is 2, times g of 3 is 4, plus f of 3 squared is going to be 5 squared times g prime of 3 is going to be -1. So we have 10 times 8 plus -25. So it's 80 minus 25, which is something. I'm not going to subtract that right now. Or I guess I could, is 55. I'm out of space. Okay, so 55. Hopefully that's right. Yes. Okay, so that's that one. I'm going to erase just this part, so give me a second to do that. I wish there were a more efficient way to erase this. This is kind of inefficient. Okay, and get my pen back. So number 17, that's a 1, 17. Let's say f of x over g of x squared, just so it's different. So if we take the derivative of that, we see that we're going to use the quotient rule and then the chain rule, or you could make this into a -2 and use the product rule. I'll go ahead and use the quotient rule. So it's going to be low, so that stays the same, d high, which is f prime of x, minus high, which is f of x, d low, which is 2, okay, pretend that's there in the right place. So 2g of x times g prime of x. Actually, let me just rewrite it underneath. Oh gosh. Well, I can't undo that. Okay, I'm gonna make up new numbers. Sorry. So f of 3, let's say -4. F prime of 3, let's say that's 2. Oops. G of 3, let's say that that's 2. G prime of 3, let's say that's 1. Okay, and so the thing I gave you was f of x over g of x squared. Okay, and then I'm going to write that underneath this time so I have more space. So it's going to be low d high, so f prime of x, minus high is f of x, d low, so I'm using the chain rule now, times g prime of x, over, wow, that was really terrible. So over low, which would be g of x to the 4th power, because I'm squaring a square. So if I substitute in the numbers, which I'm going to do up above since I don't have as much space, g of x squared, or g of 3 squared, would be 4. F prime of 3 is 2. F of 3 is -4 times 2. G of x is, or g of 3 is 2. And g prime of 3 is 1. All over, oh, I said 4, but then I wrote 2. This is 4. Sorry. Okay, all over g of 3, which is 2, and then that's going to be to the 4th power. And then you could simplify that. This would become 8. This is going to be 16, but this changes to plus. So plus 16, and this is 16. Yeah, okay. So 8 plus 16 is 24 over 16, and you could reduce that more. If you divide both of these by 4, or actually by 8, you would have 3 over 2. So that would be your answer to that one. And then I guess I'll just erase the whole slide for this last one. So let's say f of 3 equals -4, f prime of 3 is 1, g of 3 is 4, and g prime of 3 is 2. Whoops, that's 2. That's a 2 there. And then we'll say that f of 4, or rather f prime of 4, is 2. Or let's say 3, so it's different. Okay, so the next problem we're going to do will be similar to number 19. And we're going to say well, I can't really change this one very much without losing the context, but this is done on page 42, so I'm not really doing anything different. It's just different numbers. Okay, so if I take the derivative, it's going to be f prime of g of x. The inside stays the same. And then I do the derivative of the inside, which is going to be g prime of x. Okay, so this is a composition of functions. So basically, it's going to be f prime of g of 3, which happens to be 4, times g prime of 3 is what we're looking for. So the x got replaced with 3. This x got replaced with 3, so g of 3 is 4. Okay, so f prime of 4, I defined it as 3. And g prime of 3 was that 2 that doesn't really fit on the screen. And so your answer for this one would be 6 if that were the problem. Okay, so hopefully that helped you so that you can approach the homework. And if you have any other questions, of course, you're always welcome to come in and talk to me, and I will help you that way.